Boom Supersonic is promising to create a new supersonic airliner to follow in the footsteps of the awesome Concorde. But lately, some questions have started to arise around the viability of the project and specifically around who is going to make their engines. Stay tuned.
No, you didn't click the wrong link. There's a backstory to this. Scheduled for this week was a video on how supersonic transportation likely isn't economically or politically viable. However, I was just finishing up my video on modern air combat and how it's misunderstood, when Mentour released a video on the Boom company and their supersonic endeavors. In this video, he covers a lot of the same things I was going to cover. I didn't want to come across as outright ripping him off, releasing what would be essentially the same video a week later. For that reason, I decided that perhaps it'd be better that I use the video as a launching point to take some of the talking points and expand upon them where it's feasible for me to do so. Though entirely fair use, I decided to reach out to Mentour and ask permission as a sign of respect and good faith. The thinking was, since it's a reply video, considerable portions of the video would be used, and fair use does vary depending on countries, so I wanted to avoid any potential misunderstandings. He was very prompt in responding to my inquiry and was very down to earth, saying he has no problem with me using his video as a basis for this conversation. So with that said, I do recommend watching his video as it is well researched and produced. A link would be in the description and the comments. Okay, with that disclaimer, let's get into it.
The question, which is your favorite aircraft of all time, has a lot of possible answers.
There are a lot of possible answers indeed, but the correct one is the F-22 Raptor.
But no airliner have ever looked as different and been as different from everything else than the Concorde was. The Concorde was a sleek, pointy-nosed, delta-wing, beautiful-looking aircraft with 4 afterburning turbojet engines that could fly at twice the speed of sound, as high as 60,000 feet. So I am willing to bet that even if the Concorde isn't your all-time favorite aircraft, it is likely high on your list, and it certainly is on mine. So I think it's really sad that the Concorde was retired without anything to replace it back in 2003. It was sad, but not entirely surprising. And why is that, you might ask? Well, there is still some debate whether or not Air France and British Airways ever really managed to run their Concorde fleets with any consistent profit. Although talking about pure profit from an aircraft type is a bit unfair on Concorde as a design, because some of its high costs simply had to do with the small number of planes that were ever made and the limited number of routes that they were able to fly on.
So the question of profitability is probably going to be the biggest factor as to whether or not supersonic transportation is going to be viable, since of course this is for commercial endeavors. When he says cost was high due to there being so few aircraft, that is because of economy of scale. The economy of scale dictates that the cost of purchasing and maintaining a product will reduce as more of the product are made and sold. The main reason for this is because the research and development behind the product needs to be recuperated to turn in a profit, so initially prices will be high. As research and development is recuperated, the price can be lowered, potentially increasing the number of potential buyers. As more purchases are obtained, this further improves the market for the product, meaning it becomes viable to reduce the price of the product to entice purchases, to a point. As more products hit the market, the manufacturer also has to contend with those products being sold on the cheap on second-hand markets as well, also promoting a decreasing price with time. This also helps with maintaining the aircraft as well. The more people buying a product, the more parts are being produced to fix those aircraft. One of the issues the Air Force has run into is several of their aircraft require cannibalizing parts from retired aircraft, as they are no longer produced in mass quantity. If there are no parts, then they must be created from scratch. Since they're not being produced on a mass scale, that means you lose the efficiency of a mass production, costing more money. Alternatively, you can entice a company to continue making parts by paying a huge amount of money for parts, which is then used by the company to recuperate the lost economic opportunity. The idea is the company could use their workers and capital to create something that has a higher demand, making more money. By paying more for the product, you help make up for the opportunity they're missing out on. We see this with the F-22 and B-2, for example.
For normal flights, the economics of keeping these jets profitable were more challenging. They burned an enormous amount of fuel per passenger, and the noise footprint would not be acceptable today.
The noise footprint isn't acceptable, but fuel consumption isn't either. A paper released by the International Council of Clean Transportation performed a computational analysis, pitting an outdated boom design against subsonic aircraft and routes flown by the Concorde. To make these calculations, they used SWAV, which is an open-source tool developed primarily by Stanford University. Again, they used Concorde as a control to verify the accuracy is satisfactory. They found after running the simulations that Boom's old design would consume 3 to 7 times the amount of fuel of a subsonic aircraft. Now yes, they used an older design, not the current one, but the point still stands that supersonic transportation is extremely resource intensive.
Boom is planning to use the huge technological leaps that aviation industry has enjoyed in the decades since the Concorde's launch to produce a fitting Concorde replacement, one that could be truly profitable and still relatively green by making sure that the aircraft can be run 100% on sustainable aviation fuel. Today, the Boom engineers are benefiting from things that the Concorde designers could only dream of. Things like advanced composites for lightweight structures with unusual shapes, much more knowledge on advanced aerodynamics, and of course, hugely more efficient engines. The aircraft that Boom is working on is called the Overture, and we have already seen a few design iterations of it. Initially, it was supposed to be fitted with 3 engines, 2 under the wings and another one installed in the tail, kind of like on the DC-10, but Boom eventually moved away from that design, partially because that configuration might have required a different engine to be fitted in the tail than those under the wings, and operationally and in terms of maintenance, this would have been far from ideal. I don't know if I've ever heard about an aircraft that runs different engines on the same airframe.
I have nothing to add with this, I just thought it was amusing. During the 1950s, you would see aircraft with both jets and props, not because it was ideal, but because jet engines were still in their infancy and had serious shortcomings that would be overcome later. This was essentially to fill the gap.
So Boom modified the Overture, revealing its definite design in July this year, 2022. In its final form, the aircraft now has 4 engines, all under the wings, and has many similarities with the Concorde, but also some crucial differences. The Overture will, for example, be able to carry between 65 and 80 passengers, and that's to be compared with Concorde, who was able to carry 100 passengers. And its cruise speed would be Mach 1.7, which is slower than Concorde, who typically cruise at just above Mach 2. The Overture and the Concorde will have the same maximum cruise altitude of 60,000 feet, but the Overture will have a bit longer range, 4,250 nautical miles to the Concorde's 3,900.
So right away, that range is not ideal for the already limited routes it's intended to fly. It's good enough for the transatlantic flights, but flying from the US to Asia is going to be abysmal due to the range and the jet streams working against it the entire way. Not so much a concern for fighters, since they can buddy up with the tanker, but a concern for Overture. From takeoff to cruising at 60,000 feet on Mach 1.7 means a lot of time is spent accelerating and decelerating. The descent isn't so bad, but the ascent is brutal, as you're attempting to climb and accelerate, which means you're running the engines at high power settings, and you're flying in less than ideal circumstances for efficiency. With the Pacific being as massive as it is, that's probably your best bet for supersonic air travel, as the length of most flights is long enough to cause potential health concerns like blood clots. Despite that, we have a proposed aircraft that's just not suitable for these trips.
In early September, the news broke that the engine manufacturer Rolls-Royce would not be making the engines for the Boom Overture. This was big news because when Rolls-Royce partnered with Boom in July 2020, it was a huge boost of confidence for the program. It turned out though that the relationship between Boom and Rolls-Royce wasn't officially a partnership between an aircraft manufacturer and an engine manufacturer, even though that's what it sounded like. The two companies described their relationship as an engagement agreement to explore the pairing of a Rolls-Royce propulsion system with Boom's flagship supersonic passenger aircraft. But like I said, in September, Rolls-Royce announced that its contract with Boom was now completed. The engine maker said that it delivered various engineering studies for Boom's Overture, and in the company's press release, it also included the following statement. Rolls-Royce has determined that the commercial aviation supersonic market is not currently a priority for us, and therefore we will not pursue further work on the program at this time. It has been a pleasure to work with the Boom team, and we wish them every success in the future.
This is a big deal because it echoes what I've been saying in that producing an engine for the supersonic regime is extremely expensive, niche, and will never meet ICAO's emission or efficiency standards. Even if you mitigate the efficiency curve with something like Advent, you're still running the engines at a higher power setting than if you were subsonic because you have more drag to overcome. There's just no getting around that.
So finding an engine with the right thrust and bypass ratio that would suit Boom's Overture would therefore be difficult but not impossible. And there might actually even be one design out there that is really close to being perfect, and that design is the General Electric Affinity. This is a conceptual engine design that General Electric was developing for the Aerion Supersonic AS2 business jet. Now, sadly, Aerion closed its door last year because of a lack of funding, but the General Electric Affinity plans still exist and are very close to what Boom is looking for. It has a thrust of 16,000 to 20,000 pounds, that's 71 to 89 kilonewtons, and it's suitable for supersonic applications because that's what it actually was made for. The General Electric Affinity uses the same core design as the CFM56, and that's not so surprising because the core of the CFM56 originally came from a military engine, the General Electric F101. Various versions of the F101 are still powering a lot of big and small military jets today, ranging from the F-16 to the B-1 and even the B-2 bomber.
This will be brought up again at the conclusion of the video.
This was an engine that GE could make by adjusting, updating and combining technologies from its military and commercial jet engine designs. So is there a possibility that GE might fund development of such an engine for Boom and its Overture? Unfortunately, it turns out that the likely answer is no. In an interview with Leham News, General Electric stated that it is not interested in working on an engine for the Boom Overture. Now, it is worth pointing out here that in case it isn't already obvious, for any airliner, the engines it will use are a make or break factor in its success. If you don't have an engine, you don't have an aircraft.
This is true not only for airliners, but aircraft in general. Usually you won't see a new fighter generation until you have a significant development in regards to power plants. For this reason, aircraft like the J-20 have been produced in very low numbers as the PLAA waited for the WS-10 engine to come online. The fact there is no engine lined up is extremely concerning. That said, I don't think it makes or breaks anything until the baby boom starts collecting numbers. The decisions by these engine manufacturers will truly determine the viability after that. Mentioned before was the F101 engine, which uses the same core as the F110, which is also used in the F-16C Block 50. In this configuration, it produces 29,000 pounds of thrust at sea level. I want to use DCS just to visualize the concepts discussed in this video. Also, the F-16 offers probably the best argument for supersonic feasibility, as it is unstable in the pitch regime, is small with low drag, uses only a single engine, and while not needing to be profitable, still needs to be economic, as it has to have a long range. Here we have the weather replicating a standard ICAO day. At 58,000 feet, we're achieving Mach 1.8, which is about the same speed as Overture. We are consuming about 15,400 pounds of fuel per hour. Here we are again, same location, same weather, at 34,000 feet, flying at 0.85 Mach. Here we are consuming only about 3,500 pounds per hour. Even for an aircraft purposefully built for supersonic speed and not designed to turn in a profit, it's still not worth it to cruise supersonically, for the simple reason that you're not maximizing the value of the fuel. Thank you for watching. We hope you found this entertaining. We do highly recommend you watch Mentour Pilot's video on this matter, as he covers points that weren't covered here in better detail. If you enjoy this type of content, then please subscribe. In the meantime, enjoy your dance with the angels.